2012 Canadian Open Mathematics Challenge, Part A. Determine the positive integer n such that 8 to the power of 4 is equal to 4 to the power of n. 8 to the power of 4 is 4 to the power of n. Let's put this all in base 2, so this would be 2 to the power of 3, all to the power of 4. This is 2 to the power of 2 to the power of n. So now using exponent laws, this is going to be 2 to the power of 12, and this is 2 to the power of 2n. The bases are the same, so the exponents are the same. So that means that 12 is equal to 2n, and therefore n is equal to 6. Let x be the average of the following 6 numbers. Determine the value of x. Okay, well, we all know how to calculate averages. You add the numbers, and then you divide by how many numbers there are. So in this case, it's just pretty straightforward. Add them up and divide by 6. And you can add them up manually if you'd like. I don't even know if this saves any time, but I'll break this up into components like 12 plus 400, 12 plus 800, 12 plus 1200, because as you can see, they're all in that sort of format. They're all 12 more than a multiple of 400. And then, like I said, I don't know if this saves any time, but this basically becomes 6 times 12. And then it's a little bit easier to add these guys, I think, than having a 12 in front. So that is what, about 6,000. So there you go. And then divide by 6. And then this is now just 12 plus 1,000. So which is 1012. So in any kind of method that you choose, the answer should be this. Let A, B, C, D, E, F be a hexagon, all of whose sides are equal in length and all of whose angles are equal. The area of the hexagon A, B, C, D, E, F exactly r times the area of triangle ACD. Determine the value of r. All right. Well, first of all, if you have any kind of shape, the internal angles should be calculated first. So this is a hexagon, right? So even if you didn't remember this, hexagon, as you can clearly see, is divided into 4 triangles. So the sum of the internal angles will be 4 times 180, since the sum of the internal angles of a triangle are 180. And therefore, all of those internal angles, if you add them up, will be equal to 4 times 180. Now, how many internal angles are there? 1, 2, 3, 4, 5, 6. In this case, 6. So 720 divided by 6 is 120. So that means each internal angle is 120. Okay, I think I should blow this up just a little bit. Yeah, I think that's good enough. Okay, now I'm going to draw a couple of lines. I hope 2 lines is good enough. So one from A to E, and then one more from F to that line that I just drew. And that, of course, is a right angle. And I think that should be sufficient to solve this question. Okay, so we figured out that our internal angle is 120. So that means this is 120 right here. Now, they told me that all sides are the same in length, so that means that this is equal to that. So this is essentially an isosceles triangle right there. And therefore, this angle is the same as that angle. So if that's 120, then those other 2 angles add up to 60. So each of those is 30. So that's just very simple angle chasing. Okay, great. Now this internal angle also is 120, but that's 30. So that means that this is 90. So that's a right angle. So that's very, very good. Okay, now they never told me any kind of dimensions. Not a problem. I can just give dimensions. You can use x if you want. I'll just use 1. It doesn't really matter because in the end, you're looking at a ratio. So no matter what you choose, the ratio will be the same. I'll just call that side 1. Now, if this is 120 right here, then that line from D to A, this line right there, that cuts that angle in half. So that means each of these are 60, this 60, and that's 60. And then this is a right angle, and therefore this is 30. And then therefore this is 30. And therefore this is 30 also. And this should be 120, and it is. So that's just simple angle chasing. This is 90 since I drew that line as perpendicular, and this is 60. So I'm just trying to figure out all the angles. Okay, now that we've done that, we can now proceed with the question. They tell me that triangle ACD is what we're comparing. Triangle ACD. Now what is the area? 1/2 base times height. The base is 1, but this is the height right here, AC. Okay, well, I'll draw that triangle again here. I don't want to make that diagram too messy. So this is that ACD, right? And this is a right angle. This is 1. Well, the ratio of the sides of a 30, 60, 90 triangle are 1, 2, and root 3. So since I called that side 1, this side, the length is root 3. It's just very basic, mathematics with regard to a 30, 60, 90 triangle. Keep it simple. So therefore that height is root 3. So that root 3 over 2 is the area of ACD. Okay. Now they tell me that the area of the entire hexagon, A, B, C, D, E, F, G, is R times, so I'll just call it hexagon. The area is R times the area of ACD. So R times root 3 over 2. Like that. Okay, so that is what we have to work with now. Well, this triangle right here, let's just do it on the side here. ACD, we just figured out was root 3 over 2 in terms of its area. By symmetry, that is also going to be exactly the same because it has the same dimensions. So that triangle is AED, and that's also root 3 over 2. And then now all we have to do is figure out the areas of this guy and this guy, but those two will be exactly the same because of the symmetry of the diagram. So this one should be pretty easy. All I have to do is just get the dimensions. Well, AF, that side, is equal to 1. So again, I'll draw it on the side here to get the dimensions. This is A, this is F, and this is 1, and this is 60, and this is 30 in terms of its degrees. So the ratio of the sides are 1, 2, and root 3. So that means that this base is going to be a half in terms of its value. Okay. All right, great. So now I can figure out the area of AFE, triangle AFE, that big one. Triangle AEF, or whatever, that's 1/2 base times height. Base is this whole guy, which pretty much is the same as AC, and that's root 3. And then the height, we can use that, which we just calculated over here as a half. So that's root 3 over 4. And then very similarly, ABC, that triangle, is also root 3 over 4. Okay, so we got it all. So the hexagon is this plus this plus this plus this. So root 3 over 2 plus root 3 over 2 plus root 3 over 4 plus root 3 over 4 is equal to R times root 3 over 2. Okay, let's add this. Let's see, 1, 2, 3, 4, 5, 6. 6 root 3 over 4. And that's R times root 3 over 2. So that means this will be 12 over 4. R will be equal to 3. And that is what they wanted in this question. 12 different lines are drawn on the coordinate plane so that each line is parallel to exactly 2 other lines. Furthermore, no 3 lines intersect at a point. Determine the total number of intersection points among the 12 lines. Okay. Oh boy. All right, so let me just draw this. So I've got So what I've done is I've just sort of said, let me just look at 3 of these sets. This one, and this one, just for now. I'll look at the 4th set later. And when I look at that, I drew it in a way that it would appear very much like the way they've shown me. Okay, now all I have to do is just count these intersection points. All right, so here we go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. All right, great, 27. Now I'll throw in this guy, and then let's see what happens. But I've got to make sure that I draw it properly. So here we go. All right, so there's that 3rd set, and let's count the intersection points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and all the way over here, 19, 20, 21, 22, 23, 24, 25, 26, 27. So another 27, and therefore the total of intersection points, total number, is 54.